So boys, now we are starting off with question number 13 of exercise 11C. So in this question we are talking about two different shapes, like I've drawn over here. Two different shapes. One is a pentagon with 5 sides, 1, 2, 3, 4, 5, and another is a hexagon with 6 sides, 1, 2, 3, 4, 5, 6. 6-sided hexagon. And this side is basically inside the hexagon. It is not a part of this pentagon, neither a hexagon. So the first part says that find ABP, that we have to find out this part. Look, ABP. ABP, that means we have to find out which part? ABP, this whole angle. ABP, this whole angle we need to find out. So for that, if we just find out the size of each interior angle of a polygon of this regular hexagon, each interior angle if we find out, so definitely we will know the value of this B also. So we use the formula n minus 2 into 180 upon n. Since it was a hexagon, so number of sides were 6. 6 minus 2 up into 180 upon 6, we got 120. Then moving on to the next part, which says PQX. About PQX, that means they are talking about P, Q, and X, this part. So for that, if we want to find out PQX, it is pretty much obvious that this angle Q is equally divided into two parts. Like this was the whole interior angle of this Q was 120, as it is the size of each interior angle of this hexagon, and it is divided into two by this line. So this will be equals to 120 divided by 2. So 120 divided by 2 will bring 60 degrees. Then moving on to the third part, it says AXB. A, X, and B. We have to find out this angle. So for that, as it is known that ABX equals to 60, look here. Since this angle, this whole angle was 120 and it was divided into two parts through this line, so this means that it is 60. This 120 is equally divided into 60. My diagram is not that perfect. If you look in the book, you will get a more clear idea that this is 60. Since this is 60 and this triangle is an equilateral triangle, so this will also be equals to 60, and this side will also be 60 degrees. So with this reference, we get the value of AXB equals to 60, since this is an equilateral triangle. Then moving on to the fourth part, it says ABC. ABC, that means A, B, and then C. We have to find out this angle. So for that, what we have done is we simply sort out the value of, like if we want to find out this part, so easy way out is if we find out the value of each interior angle of a pentagon, because this is a pentagon, and if we find out the size of each interior angle, definitely we'll be familiar, or we will be done with the value of B. So we did the same. We use the formula n minus 2 into 180 upon n. Since this was a pentagon, so we use the value of n as 5. 5 minus 2 upon 5 into 180, we ended up with 108 degrees. Now moving on to the fifth part, it says ACD. 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 I've drawn the triangle here. ACD. Now since we want to find out the value of ACD, and it will be easier for us if we sort out this particular angle. As we know that according to the previous, by the help of previous part, we sorted out the value of B ABC, it was 108. So with the help of this angle, we can easily find out the value of the rest of these two angles. Since this is an isosceles triangle, the value of these two angles will be 180 minus 108 divided by 2. Since these two angles will be same, being isosceles triangle, so the value of these two angles will be 72 degrees. So as I can see, show you over here, that ABC was equals to 108. We divided 108 by 180, we got 72. Then 72 divided by 2, sorry, it will be 72 divided by 2 is 36. That means this will be 36. This will be 36 degrees. And now, since we know that we sorted out that the value of each angle in a pentagon is 108, that means this hole is 108. This hole is 108. This hole, out of which this part is 36. If we want to know this part, what we do is 108 minus 36. We get value of this part, which is 72. Sorry, 72 degrees. So out of this 108, if we subtract this 36, we will get the value of this remaining angle, which will be ACT. Moving on to the last part, it says ASE. 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 I can show it over here also. ASE. So what do you think can be the possible way to find out the value of S in this question? Is there any clue? What I think is, if we find out the value of A, since this is an isosceles triangle, I've redrawn it over here. This is an isosceles triangle. Once we find out the value of this A, we can easily subtract it from 180 and then divide it by 2, we will get the value of the rest of these two angles. So for the value of this angle, as we know that this whole hexagon's interior angle was equals to 120 plus this whole pentagon's angle was equal to 108, and this whole circle is equals to 360. So out of this whole 360, if we subtract this 120, this 108, we will get the value of this A, which is 142. And if we subtract 142 out of 180 and divide it by 2, we will get the value of these two angles. I have done it over here. 360 minus 360, this whole is a 360, out of which this whole part is 120. This whole part is 108. If we add these two, divide minus 360, we will get this 142. Then 142 minus 180 divided by 2 will give you 24, which will be the value of ASE. This will also be equal to 24, and same is the case with A. So this is how we find out the value of unknown angles when a regular pentagon and hexagon are merged together. Thank you.